So, and the first speaker is getting ready, but before he starts, I would like to add some background. Pere Puigdomènech has a degree in physics from the University of Barcelona and a doctorate in biological sciences from the Autonomous University of Barcelona. His current field of research is plant molecular biology and genomics. He has published 150 scientific articles in refereed journals and books, 2 patents, 5 books on popular science and scientific fiction, and supervised 18 PhD theses. He has published more than 500 articles on science in renowned Spanish as well as international scientific journals. Pere has been a member of the scientific staff of the Spanish Research Council and presently serves as research professor in its Center for Research in Agricultural Genomics in Barcelona. This all makes him a very experienced scientist, but his activities, no matter how admirable they are not the main reason why he is here, because besides these activities, he is also a board member at all European academies. This Federation of Academies of Sciences and Humanities is independent from political, religious, and commercial interests. It was founded in 1994 and brings together more than 50 academies of sciences and learned societies from over 40 member countries of the Council of Europe. Its mission includes facilitating the collaboration between academies, fostering excellence of research, representing the European Academy's position to the European authorities, and contributing to the improvement of the framework conditions for science and research. So, what is the European Code of Conduct for Research Integrity? What guidelines does it provide, and how can it help the European research institutes? These are the questions for our very first speaker, Pere Puigdomènech.
Thank you very much. Thank you very much for your invitation. Indeed, I will try to explain with the place of ethics in European research area, and including, of course, the European Code of Conduct that we have been drafted in ALLEA. I will try to share a screen. So, can you see it? Yes, it's okay?
Yes, we can see the screen.
Okay, excellent. Then this is the subject. And just to introduce you the importance of this subject, you will see that if you look at the program guide of the present Horizon Europe project, you will see the number of table of contents, number different numbers, and in 12 you see ethics and integrity. So this is an important issue when you want to apply to European grants. And there is a guide to complete what is called the ethics self-assessment. What kind of questions are there in these guidelines? You see, you have to answer questions about whether you use human embryonic stem cells. I will just discuss a bit this question: humans, human cells, personal data, animals, if you are collaborating. So a number of issues that are considered part of the need to answer when you are applying European grants. For instance, you have many questions, but for instance, environmental, health, which are also quite important, and even questions like consumer safety. If you have any during your work, you have to deal with questions with health and safety of work.
Mr. Puigdomènech, we still see the first slide.
No, I am passing.
Still the first slide.
No, I have in my screen, I am passing the, so I don't know what is happening. Ask your technical issue, because from here, from my computer, I am passing very happily the different questions. What do you see at this moment?
I see the research integrity in the European context, and now it switched to the second slide.
Okay, good.
Now it's wedged. Good.
Is European grants.
Yes.
And you see here ethics and integrity. Ethics, you have how to complete ethics self-assessment. You have a number of questions that I just said. And for instance, in European grants, you have, when you have some identifying issues which may be complex, and all these questions are generally quite complex. And here you see that when you look at that, at the end, there is the light in the light of European Code of Conduct for Research Integrity that I will talk. Why are we asked to do that? You see, the origin of these questions may go to the Second World War, when bioethics was raised in the light of the type of experiments that were done during the war. And the first code of good practices in bioethics was the Code of Nuremberg. And then already there in the court of the Nuremberg, some aspects on how to deal with research regarding, for instance, human subjects were highlighted. You cannot do experiments without consent of the persons with a benefit. So then there are a number of laws that mostly at this moment there are in European and national laws. One of the questions that you've seen in the guideline is, for instance, European research on stem cells from human embryos. And in Europe, that may be complex. It's an example of the complexities in European research, because there are countries that research where research is allowed with conditions. There are countries where no research is conditioned. So what European Union should do? And this is an example of how ethics thinking, ethics reflection may be important for science. To answer this question, the European Commission asked, which is called European Group of Ethics, already in 2007. So the Group of Ethics on Science, which is a group of philosophers, scientists, jurists that advises the European Commission. This is, you see, a number of people. I have been a member from a number of years. And there are a number of questions that are addressed to this group of reflection, you see, new developments in agriculture, nanomedicine, technology. So different European countries have different cultural traditions, different economic implications. So what was the conclusion of thinking of how human stem cells are there? You see, for instance, the attitudes of different countries is very different. Some countries are very open in the use of these cells, like UK or Spain, while other countries are reluctant, like Austria or Poland, for instance. So the recommendations of the European Group of Ethics that are now in force, so is that you have to, European Union can fund this type of research, but not in countries where this is forbidden, but you can fund that in other countries. And to a number of recommendations of minimizing the use, of maximizing other alternatives. So this is the kind of thinking that allows us to go ahead when there is some kind of ethics questions. But we have other requirements, for instance, animals, the use of animals. You see, we have a directive on the protection of animals used for scientific purposes, based on the 3 Rs, replacement, reduction, refinement. And we have animal experimentation committees. It's another example of regulations. Or, for instance, genetic modified organisms. When you think that you can put, for instance, some genetically modified plant on the field, there is also a directive that regulates this kind of experiments. So, why ethics in research? So we have different levels of ethics. The one that I just explained you is compliance with existing regulations. For instance, human subjects and materials, but increasingly data. Data have to be increasingly regulated. For instance, data on persons, privacy protection, data on us. This is very big issue at this moment. Animals, environmental, labor laws, and many other aspects. So this is one aspect of ethics and research. A different aspect of ethics and research is advising public. I will pass very fast on that. And here we have conflicts of interest. For scientists, we can be working in a specific subject. We may be collaborating with industries, which is very important in our countries. But at the same time, we may ask to advise public bodies on pharmacological products, on different products, on environmental questions. Then research integrity, the second half of my talk will be on that. And then participation in public debates. At this moment in Europe, for instance, we have a big debate on genome editing, for instance, in humans, in animals, in plants. So how we have to take part in these debates. All these are typical ethical issues. Conflicts of interest is very clear. We have, I will put you two examples. One is the biomedical research. In Europe, medical treatments and medical products are done by the European Medical Agency. And there has been a number of conflicts that they are very sensitive for our society. So there are a number of rules. Are you, for instance, for a scientist, we are asked, are you funded by some industries? You have, so there are a number of questions. For instance, the European Medicines Agency has a number of very clear definitions on what conflicts of interest says. For instance, employment of company, consultancy, all these questions. We have to be well aware that this is very sensitive for our society. How European Medicine Agency deals with, there is a declaration, so it is important of procedures and procedures to deal with that. The same thing, for instance, in EFSA. EFSA is the authority of food safety. It deals also with very important questions about safety of food, on additives, and many other questions, with GMOs in particular. For instance, GMOs, working with plant genomics. I have been a member of the panel of GMOs, for instance, which is in the center, you see. When approving some of these modified plants, the risk assessment opinion, which is a scientific opinion, is in the center. But this is a very complex issue, you see. It's a very complex and expensive aspect, and there are people who are against all these questions. So the chairman of this panel has been once sent a bomb in Parma. So you see, it's a very contentious and complex issue. So also just passing very, very quick, we have also some conflicts of interest in choosing research subjects. Collaboration with industries is important, but there is also, especially for public scientists, what is the common good. And so here we have also quite a number of complex issues that we can see. For instance, for complex, we are asked to always think about sustainable development goals, for instance. So it is, so I mean, those you see are complex ethical issues, and I will now go specifically towards research integrity, which is one of the subjects of this meeting. So why research integrity is important for us? Research integrity is important because credibility of science relies on the quality and reproducibility of results. If we are not publishing our results, if not making them public, scientific results are useless. We keep the results for ourselves, but these results have to have the adequate quality and in particular have to be reproducible. This is one of the conditions for publications. For decisions, there are a number of codes of good scientific practices. This is relatively complex because you see, as in this table, it shows that from error to fraud, there are a lot of gray areas. You, of course, as anyone, scientist, in our practice, we may deal with errors. We can make mistakes. And we have to accept that these things, for instance, our observations may be wrong due to technical issues or because it was not well designed at the beginning. But you see at the end, there is what you call publication. Some people at some point may publish or say to publish results which have been fabricated. This is something that is completely unacceptable for science, of course, because you are dealing with a completely an activity just against the practice of science. But between error and fraud, you see there are a number of different species. We will discuss that. And some aspects may be not intentional. You may make a mistake that you are not aware of that at the beginning, or it may be intentional. So all these aspects can be, and you see in the middle, we have from wrong observations that may be non-intentional error to wrong analysis and declare conflicts of interest. We just talk about that. The conflict of interest is very important now. When you publish, you have to put in the acknowledgements exactly how the work has been funded. Who is in care of that? Because of course you rely on this funding for your work. Publication bias. We will discuss a bit the question of publications because this is one of the main source of conflicts. Undeserved authorship, which is another good example. Suppressing data. You can be in your publication. You may choose to show part of your data, not all of them, and that may create different types of data. And then the most typical example of misconduct, which is plagiarism, falsification of data, and fabrication of data. Those are the most well-analyzed type of fraud in science. So to deal with that, in ALLEA and in the European Science Foundation, already in 2010, we published what is called the European Code of Conduct for Research Integrity. This is it's available through internet, if you like. It's a relatively complex document that tries to highlight, to define which are the principles that are basing scientific integrity. And these principles include honesty in communication, reliability, objectivity, impartiality, openness and accessibility, duty of care for everything, for subjects, for persons, for everything, fairness in providing reference, responsibility. So a number of questions which for a normal practice of scientists, it may seem something normal. We know that is our day-to-day way, but I mean, the codes try to define and to make it explicit. So in the way, especially for the training young scientists, but also for seniors that are those responsible of research are important. And also it defines misconduct. Here you see there's also the description of this fabrication, falsification, or plagiarism, but other aspects. For instance, one other form of misconduct is, it says here, failure to meet clear ethical and legal requirements. This is what we say at the beginning. It's what the European projects ask for, that you declare, that you are aware, that you are working in a legal framework with human subjects, with animals, with environment, with a number of aspects, and that you know they have to comply with that. This is one of the ethical requirements that is present. They are present now in many forms when you apply for grants in Europe, in private foundations, in many other aspects. And there, as it's case here, minor misconducts that may not lead to formal investigations, but they may be very damaging. The number of papers that have some minor aspects of bad practices, it has been analyzed. It's complicated, but some people say that more than 30% of papers published have some kind of misconduct, even if it's minor. This is a very discussed question. The question is whether the problem is increasing. One of the ways to measure this question is the number of retractions. When a paper has an important problem in the data, in the interpretation, in the way it has been doing, very often journals are asked to retract the paper. And this, as you say, this is very damaging for the persons who have been working on that, especially for junior persons. It's very damaging for institutions, for everyone. But the number of retractions have been rising. There is also a discussion here whether this is because people are increasingly aware of the problem, and for these reasons we will just discuss. It is more people who are analyzing papers for its consistency, and then the number of retractions are increasing, or people think that this is due to the pressure. I mean, scientists are asked to produce. They are asked to publish in high impact journals, and that may be even their own promotion, even their own salary may depend on that. So this is that makes that in some cases, especially in some countries, this makes that scientists to find some shortcuts and try to publish fast and maybe in an improper way. So there is discussion on this matter. This is a discussion: is there really a reproducibility crisis? This is a matter that has been especially discussed from the industrial sectors, because they say that when they try to reproduce data that have been published, especially in the biomedical field, they cannot reproduce. And this, of course, is extremely damaging, because not only for reputation, but also, of course, for the progress, especially if you want to look for new pharmacological products, new treatments that may be specifically very damaging. For retractions, I can advise you to go to a website which is called Retraction Watch. Every day they publish the papers that have been, a selection of papers that have been retracted, and you can look at what kind of effects that has. There is another website, it's called PubPeer, that you can also enter. Every day 10, 20, 30 papers are denounced, and there are denunciation that this is anonymous. You can enter this and you can say, you see, I've seen this paper, this figure has been fabricated, and then the authors may respond or not, and they may inform the journals. So if you go there, you will see that the number of the scrutiny that papers are being followed, it's very high, and that may also have an effect on our scientific career. And finally, I put this publications ethics organization. This is an organization of publishers, of scientific publishers. Here, if you are interested, you will find how to deal with these questions, the ways that papers have to be prepared, the limits. Of course, for instance, figures, as we will see, figures. Now, when you publish something, you have to prepare, of course, your data. And of course, this is necessary, but you have to keep the originals. Now, more and more, you are asked to keep the originals public or in reservoirs that you can use. So, I mean, all this, you can go and see what is happening. Put here, for instance, that, I mean, there is a list of papers of people who are saying, you see, in this paper, this question has been manipulated, and so this is quite important. There are now softwares for plagiarism. Plagiarism can be detected. Many journals are using them. Of course, this is very damaging. If you use the text or the ideas of someone, you have to refer for that. It's part of our scientific work. And figures, I mean, what it says here, assessing what is acceptable. So this is important, especially for young people, that we are aware that the figures have to be prepared, but some things are acceptable, some things are not acceptable. And especially, you have to be transparent of what you have been doing, because these figures are important for results that you are using. Open access is another big discussion at this moment. Of course, we are going to open research. There is also maybe a conflict when you are working with industries, for instance. So there are a number of challenges, as it says here: selectivity, the cost, the recognition, intellectual property, a number of challenges which are complex. And there are some, of course, in this situation, there are predatory journals. There are journals where you can publish whenever you like. There is no scrutiny, and you just have to pay. This is also quite damaging. And there are paper factories. It has been shown that in some countries you just want to pay $1,000 and you get a paper published without your work. So this is also something which is damaging situation. In COVID-19, there's been discussion. The number of papers that have appeared during the last 2 years is enormous. And there is discussion whether there is an alarming and exceptional high rate of retractions. Some people think that it has been a number of papers have been published very fast and without proper controls. Some other people think they're not. So this is an example of this happening. I am belonging to the Spanish Research Council. We have a code of conduct. And for instance, what kind of conflicts appear we have an ethics committee. I was the chairman during 4 years, and you see, we have every year a number of conflicts that appear to these ethics committees that exist in different countries. For instance, you can have here an example: access to facilities, plagiarism, conflicts between scientists for authorships. This is very, very normal. Questions about the curriculum. You see, this is people have to be well aware that curriculum is an essential document for science. The concerns about articles, a number of questions. In Europe, we have a network of European research integrity officers in different countries. Of course, the legal framework is different in different countries, and how to deal with these questions is different. And these kind of networks are important to check how things are being analyzed in different countries. In the States, that was the first one, the Office of Research Integrity of the Department of Health for NIH. It has been very active, and in the States, this may be dealing with the office every year has a number of cases that they analyze, and if they find guilty, they may have even juridical consequences, or they have to negotiate some penalties to these people. Right? All these things are open in the States. You can go there and to see what is happening in the States, that they are working in these questions for more than 40 years. So what is the European Code of Conduct of Research Integrity? You've seen that European Commission refers to this code. Now, when you apply for a European grant, you have to be acknowledged that you know that this code of conduct exists, and that the conditions that are presented here are going to be followed by your institution. What are the principles? This code starts with the principles that are essential for scientific activities. Reliability in ensuring the quality of research is what we have been saying. Honesty in developing everything, including reviewer, reporting, communicating. Respect for colleagues, research participants, for all, even for the environment, and accountability for the research. You have to be accountable for its management, for training, for all these questions. What are the good in the code? There are good research practices in different aspects. In the research environment, in training, supervision, and mentoring, this is an essential point. In all our scientific institute, in the research procedures, safeguards, data practice and management, this is increasingly important in all our work. Collaborative working, this is a complex issue, because you may very often collaborate with people from different countries that may have different environments, or even with different disciplines. And different disciplines have different ways of dealing with data, for analyzing data. And it may be quite complex. Publication and dissemination, we have been discussing. Review and evaluation and editing is also absolutely the key of these matters. Training, supervision, the code, as it says here, there's emphasis on training in research design and methodology. This is clear the key of the question. In our research institutions, we have senior people, we have technicians, we have junior scientists, and the relation with all these things may be complex. What is supervising the duties of everyone? So here it says that all people will have to undertake training in research. Research procedures, in the code, there are revised, reduce duplication, research waste, the obligation of publishing. All these questions are in the code. Safeguards, for instance, trying not to discriminate in different types of, especially gender, ethnicity, and data practices, as I have mentioned. Collaborating is what we just discussed. Publication and dissemination. Publication is absolutely essential for science. Questions about authorship, and if there are errors, we have to correct. Honestly, we have to recognize there are always corrections in our publication, so you can use it if they are honest. Negative results may be important also to publish, which may be difficult in journals. What are the acceptable research practices? As we say, for instance, here we have at least republishing substantial part of our results, or citing selectively. Here we have a number of violations of good scientific practices, which have to be, well, how to deal with that? When something happens, when something appears that someone has been violating some of these research practices. As I told you, there are research officers in many countries that have to deal with these questions. And this may be delicate. You see, because you are dealing with something that it's essential for instance, the personal reputation of the person. So you have to have procedures on that. They have to do it in a fair way. And as it says here at the end, anyone accused of racist misconduct is presumed innocent until proven otherwise. But this is maybe a very complex issue, but you have to deal with them when these things happen. So just to finish, I would like to give you some training tools. There are training tools on research ethics. For instance, there is the Embassy of Science that has a number of training aspects, especially for young people. The Austrian Office of Scientific Integrity has also a number of very clear ways to inform people and to train. And NEMBO, for instance, it has been very active in producing resources to foster research integrity. Thank you very much.
And we do thank you,
Mr. Puigdomènech, for all the information. It was quite complex. And it was really nice, 101 to the ethics in science and integrity in research. Well, I can't see any questions right now, but I would like to ask something. Do you have any feedback on which level the implementation of the rules is within the different countries in Europe or within the different research institutes?
Well, as I told you, in Europe, different countries have different legal frameworks. They have different traditions. And some countries have produced, I just refer to Austria, but I mean also Finland or the United Kingdom, now France, have their own offices of research integrity. Institutions, many institutions I know in Germany, for instance, Max Planck or the FG, they have their own code of conduct. I know that, for instance, even private foundations, for instance, the Wellcome Trust or Novo Nordisk, they have different rules. That when they say that if they find that something happened very important, they will ask universities or research to bring money back. So also happening in Europe. So I mean, as I told you, I mean, for instance, in Denmark, that has a very long tradition of these questions, which they have a specific law and a specific legal committees. Every year there are a number of cases that they deal with. So the question is that, of course, we have the rules, we have that, and it's very important that everyone it's aware of that. In Europe, for instance, the European Research Council also it has their own rules, their own procedures to deal with these questions, which may be also very complicated to be analyzed in European context. So, but you have to deal with these questions because the worst would be not to discuss and to hide what is happening. Dr. Kleiman would like to say something, please.
Yes, Professor Puigdomènech, thank you very much for your talk. It was very interesting and very invigorating. I would like to ask you about plagiarism. I think this is a big topic both in Czech Republic and Slovakia, from which I come from. And I would like to ask your experience or your opinion, because this is definitely a very important ethical topic for the reasons that you mentioned. But it is also a political topic, and it is being politicized. In fact, I was quite surprised when I was discussing the reform of university education in Slovakia. I learned that one of the pillars of the reform is basically enacting already two acts combating plagiarism. as a pillar of reform of the system. I understand that this is a very important issue. So my question really is, what is your experience? Is it politicized also in other countries? And how important is this in the whole context of making the universities a better place for education?
You are completely right. Plagiarism has a number of consequences. I mean, if you produce something, I mean, our job for scientists, but also for artists, for instance, or for writers, for instance, their product, their life is the product that you have produced. If someone appropriates your own product, it takes from you, it takes your own life, in fact, your own products. So this is very important. It is different in science, probably, that what is happening in literature or in music, where it has say commercial consequences. So there are in some countries you have to distinguish the plagiarism that has some commercial consequences from the plagiarism that has not. I mean, if someone plagiates a music and it sells this music, of course it has some commercial consequences. In science, normally it may not have that just with publish, but it can be as important. But I mean, you have to distinguish these cases. Plagiarism, it may be relatively easy to discover. Now we have softwares, we have ways. Many journals use these things, these ways, and of course it may. The discussion that I've seen in some countries is that, I mean, besides these cases that also we have to deal in when I was chairman of the ethics committee of the Spanish Research Council, we had to deal with a very important case of someone who has just copied pieces exactly of other work. This is relatively easy to discover and to deal, you see. But of course, when you just cite some works of others, if you do it properly, that is the question. To not to just appropriate the text, the ideas, but to cite properly. Here, it can be some training needed. You see, how to just acknowledge that someone has said something, and you have to acknowledge properly. What you cannot say is to take these ideas to reproduce and to say that it's your own ways to do it. This is completely unacceptable. But I mean, you're completely right. It's an essential point for many cases. And we have also to recognize that in some cases, these things 10 years ago, 15 years ago, things were considered differently than they are today. It's difficult to judge a text that was produced 20 years ago with our point of view, right? You have to deal with all these questions. When they happen, normally either it's very clear, because plagiarism may be very clear, or in some cases it would need to be analyzed properly, and that may be also not so easy.